Good evening, everyone. Welcome to the first live session, weekly live session for the course on NPTEL, that is Geomorphic Processes, Landforms and Landscapes. So, this is taken by Professor Javedan Malik from Department of Earth Sciences, IIT Kanpur, and I myself am a PhD fellow in the Department of Earth Sciences, IIT Kanpur. My name is Ananya. So, what we will be doing in these weekly live sessions is that I will be first giving you kind of an overall summary of the entire week's lecture content so that it helps you to, if you have any doubts, you can clarify it. It will also serve as like a revision for you, and also the content that will be shown over here will help you in completing or in attempting your assignments. So that is what I will try to cover in these weekly sessions. Now, since this is live, I hope that you all attend this and get your doubts clarified while on the session, and so it will be a good way to interact also. And so what this course is actually, I just a brief outline. So the geomorphic processes. So geomorphic processes means that the processes that happen on the surface of the earth. Okay, the changes that we see in landscape, okay, how the landscapes are changing due to the action of natural agents. So what are natural agents? You have wind, you have water, so water as in both surface water as well as your groundwater, glaciers, and also sea waves, okay, so your coastal environment, how these agents actually transform the landscape around these areas on the surface of the earth, and all these agents they form certain kind of landforms. Okay, so how these landforms are created, what is the process, okay, so what is the mechanism behind these processes and behind the action of each agent. So these are something we will learn in this course, and this will also help us because a lot of these landforms and landscape changing actually comes into effect when we try to understand the natural hazards as well as man-made hazards. Okay, so this course this geomorphic processes, understanding them is important with that respect also. Also, which kind of areas or which landscapes, uh, are stable or they are not stable, or how the changes can, occur in future also. So, these are something that we can understand through learning geomorphic processes. So, what we will be, like a brief outline, we will be doing first the fundamentals of Earth's surface system. Okay, so the entire kind of the system, okay, Earth system is actually made up of different individual systems. Okay, they all work in harmony. They all work, in relation to each other. So we will try to understand how each of the systems interact with each other. This is in brief, so you understand how, maybe there is connection between how atmosphere and hydrosphere act together. Okay, so in that sense. Then, what is the next thing that we need to know when it comes to any processes that are happening on the surface of the earth or within the earth is we need to understand the interior of the earth. Okay, so in basic sense, we all know that earth in itself is a layered structure. Okay, and while these are, layered structures on the top surface of the earth, there are a lot of movements happening. So we will try to understand what is causing these movements. Okay, so these are also dealt in brief, and we will try to see how these also, affect the landscapes and landforms formation. Then, as I said, that we will have like different systems. So you have atmospheric system, then you have the hydrosphere or the hydrologic system. So the hydrological cycle, and the greenhouse effect, carbon cycle. Okay, so these are some of the kind of atmosphere, hydrosphere, biosphere, and lithosphere specific some of the processes and how they interact with each other. That now the main part that is kind of given in the box over here. These are the different types of geomorphology. Okay, what is geomorphology? I will come in the next slide. So for now, like fluvial is uh, how the landforms and landscapes are forming due to rivers. Aeolian is how they are forming due to the action of wind. Glacial is how they are formed from glaciers, the movement of glaciers, melting of glaciers. Okay, then you have karst. Karst is typical of areas where you have groundwater action. Okay, and then coastal and submarine is again, in the coastal areas, how the sea waves, the transgression and the regression and all those things, how they are, affecting and forming the different landforms there. So the next thing that we need to understand, why do we study the whole, geomorphology as a subject? So the applied geomorphology can come into, come in play in understanding your natural landscapes uh, together with we need to understand the environmental geomorphology. Okay, so environmental geomorphology can be affected by both natural and human influences. Okay, so together with these two, we understand the effects on the environment, okay, due to these processes. So you have human environment relations also, and then you have your cultural landscapes, as in the different heritage sites also. Okay, so what is the uh, action of these geomorphic processes in such landscapes? That too we try to understand when we know the basics of the geomorphology or geomorphic processes. Okay. Uh, so some very basic facts, but which we need to keep in mind when we are learning about earth processes. Okay, so any process on the surface of the earth is actually on the surface of the earth. Every process is a very time taking process, like the time scale that we follow in earth sciences. Okay, they range from hundreds to thousands to million and billion years scale. Okay, so the scale is very large for us. Okay, so any of the landforms that are formed, for example, if you take the Grand Canyon. Okay, so we know it's one of the major landscape or landform. It's well known. So uh, the natural agent which actually created the Grand Canyon. Okay, so that has been operating for a very, very long time. Okay, so like we cannot kind of we won't be able to understand that if we don't know the scale of the process. Okay, we would be thinking that how can a river just create this? It is not created in the last 100 years. It has been created since quite a long time, say thousands of years or even millions of years. Okay, so there are some landscapes, landforms which have been formed, okay, through a very long. So when the processes itself are so much longer in duration, so that kind of gives us an idea that how old actually the earth is, like the formation of the earth. Okay, so the formation of the earth, obviously, you know, uh, we have been dating a lot of, a lot more kind of, improvements are also happening in the dating of the earth's age. Okay, so till now, what the dating records and the oldest record that has been obtained till now. So we can say that the Earth is around 4.54 billion years. Okay, in age. 4.54 billion years plus minus 50 million years. So we have like an error of plus minus 50 million years. So this is the age that we consider Earth. So when you say this billion years, so you can understand the like right now at present, whatever landscapes and landforms that we have seen, okay, uh, they might have been regenerated, okay, or some might have formed pretty at like much older times, and they got modified due to these geomorphic processes. So geomorphic processes, in a way, since the time these natural agents started acting on the earth's surface, okay, from then the landscape has been ever changing for earth. Okay, so this is something that we need to understand. And so the oldest dating record, as I said before, till now we have had the from a zircon crystal, Western Australia, the oldest data recorded. Okay, so there might be some, Earth is obviously older than the this zircon crystal that has been there. But till now, the only material that we have got, which can be the oldest record, in consideration, is around 4.36 billion years old. Okay, so the rock. Now, for that dating purposes, we need to use radiogenic isotope studies. Okay, so they are the most reliable techniques that we have, that we are using till now. So you can have your potassium, rubidium, lanthanum, smithsonian. Okay, so these are some of the elements, okay, isotopic elements that we use for this study. Okay, so you can see that the half-life of these are actually considered. Okay, so till now we have, different half-lives, and through those half-lives we try to date them. Okay, so you have uranium and rubidium, these are very widely used. uh, so you can, these are some of the isotopes that we use. Potassium is also used. Carbon has the, smallest kind of half-life. So usually carbon can be used for the last 1,000 years, like dating any material that is only say some 1,000 years old. Okay. So now we come to the Earth as a system. Now, in basic, we have, kind of three kind of systems. You have open system, closed system, isolated system. Now, what these systems are actually considered is like the interaction or the give and take of both energy and matter is considered in classifying these systems. For a human body, we know that there is a, constant, transfer of both energy and matter. Okay, so when you have both energy and matter being transferred through a system, so that is called an open system. Okay, and in a system, if the matter is not being transferred, okay, so the matter, like there is no external input of matters, and also the matter from the system is not, getting transferred outside. Okay, but there is a transfer of energy, so that is called a closed system. And then we have the isolated system. So in isolated, you don't have any transfer of both energy and matter. So your any thermos flask, thermal, the flask that we use, or when you have vacuum sealed containers, okay, any vacuum container that we use in experiments also. Okay, so these are usually isolated systems. Okay, so we need to understand that we are only actually going to understand the closed system. Why? Because Earth in itself is a closed system. As you know, the obviously we have a matter exchange, but that is between the individual systems of the Earth system. Okay, so you have transfer of your, uh, uh, there is a relationship of the atmosphere and the hydrosphere. Okay, so that relation in itself, but both these systems are part of the Earth system only. So there is no kind of, matter being transferred outside of the Earth system itself. So, but we have the energy transfer. So that is a solar radiation. Okay, so solar radiation we sometimes also have, ionospheric currents because of these solar radiations and everything. So these kind of interactions happen. So these are in the energy domain. So that is why we call Earth system as a closed system. Okay, so this is important. So now, as I said, Earth system as its whole is a closed system. Okay, but Earth system itself is made up of different individual systems. Okay, so you have systems, or you can also call them, different spheres. Okay, different spheres. So one of the sphere is, as we know, is atmosphere. So atmosphere again is a layered, our atmosphere is layered. So the immediate layer that is close to the surface, you have the troposphere. Then on top of that, you have the stratosphere. The ozone layer, kind of marks the boundary between stratosphere and troposphere. Then you have mesosphere, then thermosphere, and the exosphere at the last. Okay, so we can see that, mostly the kind of matter exchange that we have, it usually happens in the troposphere, where you have, cloud formation, and then you have obviously cloud formation due to evaporation of water. Okay, so over here you have some matter exchange. Okay, but in the upper layers, mostly it is the energy, exchange that is happening. You have electromagnetic radiation, and also you have the, you know, uh, heat energy. Okay, so these are kind of the interactions that we have in the atmosphere. Then you have hydrosphere. Now, hydrosphere, most of us have studied the, hydrological cycle per se in our, schooling. So we have the, evaporation from the water bodies. Then it goes into the atmosphere. It forms the clouds. Okay. Then after condensation, again, it is, it transforms into your rainwater or your snowfall in precipitation format. Okay. So, and then you have the precipitation, then again the precipitation actually transform into surface water or groundwater. Okay, and these again travel back to your larger water bodies where the evaporation again takes place. So this is a cycle, and now this is also a sphere. Okay, so you have immediate interaction between atmosphere and hydrosphere. Now you have the biosphere. Biosphere is where all the living beings on the Earth's surface, how they interact with the other two spheres. Okay, you have atmosphere and hydrosphere. As you know, we require both for our, day-to-day living, and so it is important. So these three spheres, they kind of, play an active role with each other. Okay, so again, this, together maybe they like individually they can be called as, open systems, but they are interacting with each other only. And then again, there is no matter transfer outside of the Earth system as a whole. Okay, so this is where you have these individual ones can be considered as open systems. Now, even in biosphere, obviously we know that, there is exchange of matter as well as energy. Then you have the geosphere. Geosphere is actually related to all the material that is found on the Earth's surface. Okay, so you have rocks, you have sediments, you have minerals. So these are all the kind of, you know, uh, we call them as geological material. Okay, so geological material, you have rocks, and even the landforms that are created, they are kind of, part of the geosphere. How? Because weathering and erosion actually, transforms these landscapes, and with the deposition of the matter that has been weathered and eroded, those actually form either rocks as well as different landforms. Okay, so these we will learn when we are learning about the each and every agent separately. Okay, now geosphere again has to interact with your atmosphere as well as hydrosphere and biosphere. Okay, atmosphere, due to the, uh, the presence of wind. Okay, so when the winds are generated, they themselves, act on the earth elements. Okay, so then atmosphere is playing a role in the geosphere. Then your hydrosphere, as I said, when the surface water travels, okay, from the area where the precipitation has happened, where the water was collected, it will start flowing towards your sea or any bigger water body. So during that transfer of the material over there only, okay, a lot of new landforms are created. There is weathering, there is erosion. Okay, so again there is an interaction between your hydrosphere and geosphere. Biosphere, now you know that a lot of animals, some animals, they burrow. Okay, so they create burrows. So that itself is again causing some kind of, disintegration of the earth material. Okay, obviously when, animals die, they're like at least before previously, how we get fossil fuels is that the living beings, millions of years ago, they kind of got fossilized, and then we get a lot where we get the reserves of different fossil fuels. You have coal, and then you have petroleum. Okay, so this is again an interaction between your biosphere and geosphere. So you can see all these spheres, okay, all of them have a have an interaction, okay, with the different with each other, sorry. Okay, so they all interact with each other. There is a transfer of both energy and matter among these systems. Okay, so these all are open system, and these all are interacting with each other, but together they as a whole form the earth system, which is a closed system. Okay, uh, we will see later on that mostly what we will learn is how the atmosphere and hydrosphere kind of interact with the geosphere. Most of the geomorphic processes that we are going to learn is going to be related to the action of say wind and water and different precipitation forms like your snow, glaciers, and also sea waves. So that is why understanding these systems and the interrelationship that they have with each other is important to understand any kind of processes that are happening on the surface of the earth. So now we will come to the earth's interior. Okay, so we, as I told before, that we know that earth's interior is a layered structure. Okay, so each layer have different properties, and each layer like they have a different role that they play in the overall sustaining the earth system. Okay, so how that matters is suppose if the if we change anything in the earth's interior, if we say the if we call that, we know that mantle is actually it's not solid. It's mostly liquid, semi-liquid, okay? And due to its inherent property, okay, we have cells, conduction cells, sorry, convection cells, okay, that is inside the mantle. Now, if it becomes solid, then we will not have these convection scales. Okay, and if we don't have the convection scales, the crust, the Earth's crust, is not going to move. And if it does not move, we do not have any new land forming or any land being, exhumed in the processes. Okay, so it's a very delicate kind of, it's a very delicate setup that we have, and everything is sustained because of the way it is. So quickly we'll go through all the layers of the earth's interior. So we will start from the innermost layer. So that is, you have inner core, which is solid. Okay, and we know that the inner core is actually, you know uh, it's cooling. Okay, so it's cooling, and as it cools, it starts forming it becomes solid. Okay, so the outer core is liquid, but the inner core is solid. Okay, and then you have the mantle. So the mantle is actually the thickest layer of the all the interior layers of the earth. Okay, then above the mantle you have a kind of a transition layer. We call it a transition layer, that is the asthenosphere. So that is partially melted. Above the asthenosphere, the entire part can be called a lithosphere. Okay, so the lithosphere is actually, it can be divided into uh, different layers. One is your crust, and the lower part of the asthenosphere is called the upper mantle. Okay, so your asthenosphere is actually capable of flow. The flow that we are talking about, which gives rise to the plate tectonics, as we will see later on. So this asthenosphere is actually kind of, responsible for the plate movements that we see. Okay, then you have the Earth's crust. Now, Earth's crust again is divided into two. You have the continental crust, and this I'm not sure if you can see. This is the oceanic crust. Okay, so the oceanic crust is actually below the oceans and the seas, and your continental crust is all the land masses that we see everywhere. Most of them are actually belonging to the continental crust. Okay, so there's a difference in the characteristics of both the continental crust and oceanic crust. Okay, so your continental crust is actually, I'll just write it here, continental and oceanic. Okay, so continental crust is actually thicker. Okay, I'll explain. Sorry. While your oceanic crust is actually thinner in nature. Okay, why is oceanic crust thinner? Because oceanic crust is more susceptible to the destruction and newer crust being formed. Okay, so oceanic crust is constantly being, you can say it's regenerated. Okay, so part of the oceanic crust melts at one place, and then in the another part, a new oceanic crust is being formed. Okay, so the ages also of the oceanic crust is uh, younger. Okay, if you date them, your oceanic crust will mostly be younger than your continental crust. Continental crust is thicker because uh, where there are very there are few specific places where your continental crust is kind of being uh, destroyed. Mostly it is not entirely destroyed. Okay, so maybe it forms another landform over there. Okay, so continental crust is still present, so that is why the continental crust is thicker as well as it is older. Okay, and your oceanic crust is younger when compared to each other. So as I said, you have continental and the oceanic crust, and even the compositions are different. Okay, so most of the continental crust is actually made up of silica and aluminium. Okay, so the major abundant element, considering the composition of the continental crust, we can see it's mostly made up of silica, whereas uh, your oceanic crust is mostly made up of silica and mafic minerals. What are mafic minerals? You have iron, you have magnesium, manganese. Okay, so these are some of the mafic minerals or elements. Okay, so these are mostly found in the oceanic crust. Okay, while the continental crust has mostly silica, aluminium. So silica and alumina, these are actually the kind of, the ions, or they form different kind of minerals with other elements. Okay, so maybe you will have potassium silicate. Okay, so these are the kind of minerals that are found in continental, and you might have ferromagnetic silicates. Okay, so these are part of the oceanic crust, and because of this inherent composition, your continental crust is actually lighter, or it will actually, I would say, it's like less dense. Okay, less dense compared to oceanic crust. Oceanic crust is denser in nature. Okay, so you can see that while both of them are forming the Earth's crust as a whole, both of them are different in characteristics, and due to the difference in characteristics, both of them actually act in different ways when we are considering the different kind of geo processes, earth processes. Okay, not just geomorphic processes, earth processes. So any layer, as I said before, any layer, if you change something or the other in their characteristics, a very different kind of setup can be setup will evolve. So right now the kind of the system that we have, the earth system we have right now, all of these actually play an important role in that. So along with these major layers, okay, so there are boundaries which are distinguishing each and every layer. So if we start from the inner core and outer core, okay, so uh, so the core is actually distinguished from the mantle as a part of the Gutenberg discontinuity. Okay, so and if your the mantle and the crust, okay, are distinguished from each other with respect to Moho discontinuity. Okay, so these are two important zones in the interior of the earth. Okay, so where we find a distinction, uh, how these boundaries are actually were classified before is that these are the depths at which the properties of the two layers change. Okay, so your outer core property and your mantle property, they change. They are mostly the density changes that we see. Okay, and similarly outer core and inner core also, they also change. Okay, because of the difference in obviously the state of the material also, and also the density. So all of these together are forming the earth's interior, as well as I said, the earth's surface is actually made up of the earth's crust, that is your continental crust and oceanic crust. Okay, now we will come briefly to plate tectonics. As I said before, if you change anything, your entire earth system and plate tectonic processes will change. So that is why it's important for plate tectonics to occur also, to keep this ever evolving
Excuse me,
system
ma'am.
that we have. Yes,
Ma'am, I have a question.
yes, yes, sure.
We know that the asthenosphere are partially melt.
Ha, yes.
Why only the small portion of the mantle are melt? Why not some more extent?
Okay, so there is a the presence of water. Okay, so at deeper depths, and as well as when the temperature increases, the holding capacity of the composition or the material there, the holding capacity of the water actually goes away. So your asthenosphere, in that sense, the material that is present over there, they hold water, not in the sense the water that we see in kind of the surface water conditions, but the material over there, they have water in their molecules. Okay, also,
Magnetic water.
yes, so that water, the that is why the material over there, they kind of have the partially melted form. So,
Yes,
and
ma'am.
yeah, so the heat as well as the content of the water that is there because of the depth over there. So that is why you have the asthenosphere in the partially melted phase. And because of that, the plates, the continental plates or the oceanic plates that are there, resting on the asthenosphere, they can move.
Yes, ma'am. Yes, ma'am.
Okay.
Yes, ma'am. Thank you.
Okay. So, as I said, as I just explained about the, the asthenosphere being partially melted, and that is why we have the plate movements. So, we have convection cells. Okay, you can see over here these arrows that are marked over here. Okay, so the material, okay, and this is also owing to the, kind of this is a sustained process. Okay, so wherever material is going on, it is moving upwards, okay, towards the earth's crust. Okay, so the earth's crust starts moving away, and then at one place the material that is moving away, if it kind of converges with another plate, that is where some material is again being pushed to inside the mantle. So again, if it is being pushed in the mantle due to the higher temperature and also the pressure differences, the material is going to melt. Okay. Again, due to this convection action, again it is going to get diverted towards the area where the material is coming on top. So together this is called the mantle convection. Okay. So wherever the material is coming on top or towards the Earth's surface, that is where we get the newer oceanic crust. As I was saying, oceanic crust is, it keeps on getting regenerated. So if these are mostly, if you consider all these plates only as oceanic plates, okay. So over here you have the material coming on top, and these actually form ridges. Ridges as in these are like small mounds that you can find, on the oceanic crust. So these are called mid-oceanic ridges. So over here in this map, you can see, okay, all these lines where we see, okay, these are actually the areas where you have the oceanic ridges. Okay, and these areas where you have the triangles, this is where you have the material being pushed down towards the mantle because of the convergence. Okay, so two important processes actually occur due to the whole mantle convection and plate tectonic movements. One is the subduction, and the second one is uh, divergence or the creation of the mid-oceanic ridges. Okay, so if the plates, oceanic, considering only oceanic plates right now, so if they are converging or coming towards each other, okay, so this is called your subduction. And if you have the oceanic plates going away from each other and newer material, coming out from here, okay, so these are called ridges. Okay, so the process that is happening here is called convergence of plate boundaries or of plates, and this is the divergence. Divergence is that they are going away from each other. Okay, so these two are very important processes, okay, due to which we have, mountain building. If as we you must be knowing that Himalayas are formed due to the convergence between the Eurasian plate, okay, Eurasian plate and the Tibet plate. Okay, the Indian the Indian landmass and the convergence with the Eurasian plate. Okay, so Himalaya is one of the easiest examples to understand how convergence creates the landform. Okay, so mountain building is usually formed due to your subduction. So these are when we are talking about continental crust being involved. Okay, so if you have oceanic, if you have subduction, okay, and if you have continental plates, that is, being, it's between continental and continental plate or crust. So it is going to form, usually they form mountains. Okay, now if you, the subduction happens between oceanic plates, okay, so then what we find are trenches. Okay, so if you all know, the one of the most like the popular example of a trench is the Mariana Trench. It is also the it is the deepest point that has been found till now on Earth. Okay, so trenches also happen due to subduction. So trenches, how they are forming is if the one plate is moving and this is the other plate that is moving. Okay, so if they are converging. Now mountain building, it will go on top. Okay, so both the material is kind of some material is obviously lost, okay, but most of the material is actually building up on top of each other. But sometimes what happens in subduction is this one plate is being destroyed because it is going down, okay, towards the mantle, and this one is some part of this also gets destroyed, but mostly this is not destroyed completely. Now where these two plates meet, Okay, so this area actually can extend much deeper. Okay, that is when you have your trenches. Okay, so this is a very rudimentary and basic way of explaining. Obviously, each part of the subduction process also, there are different kind of geological features that are formed corresponding to your subduction as well as your divergent areas. Now, divergent areas, as I said, the most prominent feature that we see are the mid-oceanic ridges. Okay, and usually the divergence is, active between oceanic plates. Okay, so this is like a kind of a gist of plate tectonics and how the Earth's interior plays a role in the occurrence of these plate tectonics. We will learn, I think, some more part of this in the upcoming lectures when we understand some of the landforms. So now we come to the main portion, I would say, of the course, like a brief understanding of what is geomorphology or, the study of these geomorphic processes. As I said before, even in this diagram, you can see that all the different spheres, atmosphere,
Excuse me,
biosphere.
ma'am.
Yes,
One more question.
yes, yes, sure.
We know about the subduction between oceanic and continental crust. Some trenches
Yes, yes,
are formed there too, but
yes.
oceanic trenches are more deepest than continent and oceanic trenches. Why?
They are deeper. First of all, as I said, that the oceanic crust themselves do occur at much depth. Okay, so that is also because the entire water column is also present. So when we consider the depth to the trench, okay, so we consider from the MSL level. Okay, so that is one reason. And the ocean, it depends because I said that the oceanic crust is denser. Okay, so it can actually reach to much larger depths because of the kind of higher melting point. Also, the composition of the oceanic crust also plays an important role in that.
Yes, ma'am.
Yeah. So, as I said, the Mariana Trench is actually between oceanic and oceanic. It's not between oceanic and continental. So, since the continental, if you have subduction between oceanic and continental plates, okay. So, what happens is since the continental crust is first of all lighter, and due to its inherent composition, the material melts at much higher temperature, at much lower temperature, as well as it does not go very deep. It immediately converts into your, it starts converting into the mantle material. Okay, it's owing to the composition also why we find deeper trenches when it's between ocean than ocean and continent.
Yes, ma'am. Thank you.
Okay. So yeah, as I was saying that we had discussed before this about how atmosphere, biosphere, hydrosphere, lithosphere, okay, lithosphere or geosphere for that matter, how they interact with each other, okay, and how there is a transfer of both energy and matter. Now the same thing you can see in this diagram. This is a much more descriptive diagram, okay, and how these interactions between each sphere is actually giving rise to the changing landscapes, okay, the processes that are changing these landscapes, and also the processes that are going to form landforms which we see, okay. Uh, your Grand Canyon, I'm just using that as an example because it's known to everybody. So that itself is a landform, okay. So what is causing that landform is the changing of the landscape over there. What is changing the landscape? There's a natural agent that is at play over here. Okay. So your Grand Canyon, the material that is making up your Grand Canyon belongs to the lithosphere or the geosphere. Okay. But what is forming the landscape is actually uh, it is kind of a part of the hydrosphere, the surface water. Okay, so this is the it's a common example to understand how the two spheres are acting together to make the landform. Okay, so geomorphology in a nutshell, it's the study of such landforms and the processes that are shaping them. Okay, so obviously understanding geomorphology, it will help you to understand the interaction between the Earth's tectonic framework. As I said, the plate movements are kind of, the primary or the major component of the different earth processes. Okay, and how they are being influenced by the action of the natural agents. Okay, so this is we can understand the interaction between these two processes themselves, which is giving rise to the changing landscapes and formation of the landforms. And as I had mentioned before, geomorphological processes themselves are sometimes the causes of some natural hazards. Okay, so the weathering and erosion that is carried out by the natural agents, they themselves actually generate some of these natural hazards. We call them hazards now, but they are actually naturally occurring processes. Why we call them as hazards is because they are destructive to life and property. Okay, so but these have been occurring much, you know, mm, much previously to when humans started, inhabiting Earth in that sense. Okay, now it's hazardous for us because there is a lot of loss in life and property if these natural processes they happen at a higher magnitude. Okay, so most of the geomorphological processes themselves can cause such natural hazardous incidents. So there are natural hazards, okay, which is caused due to these processes. You have plate tectonic, even plate tectonic movements themselves, as we know, they can cause, very high magnitude natural hazards. You have earthquakes, then you have tsunamis, okay. So these are occurring, these have, there is no control, okay, there is no man-made or human control over these natural processes, okay. But there are some, you know, some of the processes get aggravated. Okay, the intensity of these processes increase because of human influence and human interaction. So, suppose, we excavate or we remove a lot of, material from the sides of the mountain, okay, from mountain sides while building roads. Now, landslides do occur even in natural, like when the material becomes very loose due to weathering and erosion, the material comes down. Okay, but now it gets aggravated because of human involvement. Okay, if a lot of material is removed in an artificial way, okay, not a natural way. Okay, yeah, the roots of the trees are, destroyed when, excavating or, removing this material, so there is no hold over the sand and sediments over there. So what happens is you have a the magnitude of the landslide increases. Okay, landslide is a natural process, but the magnitude has now increased, and because of these landslides, we are facing loss of life and property. Then it becomes a natural hazard. So we need to understand the effect of erosion and weathering of due to, say, air, the wind over there or the air over there, as well as surface water or groundwater. Okay, so these are natural agents that are causing the weathering and erosion. But if it is exceeded by the human influence, then it becomes a problem for us. So geomorphology, mostly we will deal with the natural processes that are, forming the landforms and, causing these weathering and erosion processes. But if we understand geomorphic processes, then we can also understand how the, influence of the human activities is, kind of enhancing these natural processes. and they are actually causing much more damage than it would be if it's just naturally happening. Okay, and important thing that now is kind of affecting these geomorphic processes is climate forcing also. As we know that the glaciers, they do melt, okay, and they do give rise to different landforms and landscapes. Okay, but if your glaciers are retreating, okay, a lot of these landforms are not formed in general. Some of these landforms are actually important for sustaining the life of the people who are staying there, staying in these regions. Okay, recently we had an incident in Sikkim, okay, where the glacial lake, there was a outburst, and more than half of that lake got emptied out. Okay, now the glacial lake, uh, like originally was formed due to the depositional activity and kind of the landscape formation due to glaciers. Okay, but as I said that natural processes, when the either the magnitude of that process, magnitude of the intensity of, if the process increases or decreases, then we have natural hazards. Okay, then we have these naturally occurring incidents which then cause problems for us. So glacial lake in itself is a feature. Okay, it could be the glaciers, it might be due to human influence over there. Okay, it might be due to sudden melting, or more precipitation that has happened. There could be an outburst because of that. Okay, so climate forcing has now, we can see that the influence has increased on these geomorphic processes. Okay, so the kind of the stability or the stable relation that usually used to occur beforehand is now not that stable. Okay, so these are all influencing the geomorphic processes that we have. So one of the key principles that we have to remember when we are studying these natural processes is whatever processes are happening right now, okay, anywhere on the earth surface, that is actually a gateway to understand the processes that have happened in the earth's past. Okay, as I said, the Grand Canyon, the example that we can see that the water is flowing. Okay, the way it is flowing right now and the way it is going to cut through this surfaces, okay, this actually gives us an idea of how it must have started from here, and then it must have cut this entire section of the land. Okay, so this is what we understand from the principle of uniformitarianism. So this is the idea that the same natural laws and processes that operate in our present day, okay, in the present day, have always operated in the universe in the past, and it is uniformly and universally applied everywhere. Okay, so this was actually given by James Hutton, and examples, as you say, the river forming valleys, canyons, and the you have sand dunes. Okay, so the way sand dunes are created now, that was the same way that have it's the same way how they were created in the past. Some of the very old sand dunes, you can find them when you are cutting or like a rock section, and you can see those features also. So they got consolidated, with years and years of buildup of sand material on top of the dunes that were formed in the in ancient, or Earth's time, million, maybe thousands and million years ago. So geomorphology is also helpful in understanding Earth's history, Earth's sedimentation history, the history of these different kind of huge landforms that are formed. Okay, So as we know that Himalaya is kind of, it is accreting together and it is forming the mountain that we see, the mountain range that we see. Okay. But along with the formation, there is also weathering and erosion that is happening. Okay. Due to, say, glaciers, due to, wind or any of the water bodies that are present over there. Okay. So they themselves are ever evolving. So some places, you would see, as we know that, the Himalayas are increasing in height every, year by a few centimeters. So, but in some places you can see the some part of Himalaya is also getting eroded. Okay, so this is the same thing, mountain building and the erosion of the mountains that we are seeing right now. Okay, so they have happened in the past too. So this is the entire understanding of how principle of uniformitarianism is actually, playing a role in understanding geomorphology and the geomorphic processes. Now, a brief kind of overview of what kind of geomorphic processes are, how they can be classified, and what are the different processes that are involved in each of these classifications of geomorphic processes. So you can have endogenic and exogenic. Endogenic are, mostly like involving within the Earth's uh, crust. Mostly they relate to the tectonic movements that we have. Okay, so you can have slow movements and sudden movements. Slow movements, as we have mountain building or continental building processes. Okay, so these are slow movements. As I said, that every year few centimeters increase in height is only possible or only happening. Okay, but you also have sudden movements. As I said, you have earthquakes and volcanism. That sudden movement of plates against each other or towards each other or away from each other. Okay, so if they happen suddenly, then you have your volcanism, earthquakes. Okay, so these are also processes which are actually, they make geomorphic changes on the Earth's surface. Now, your mountain building can happen in two ways. You have compression, where I had explained how Himalaya formed. Actually, Himalayas are due to the compression. Okay, so you have folding of the mountains, and you have fold mountains. That is, your Himalaya is a part of, it can be classified as fold mountains. But you also have mountains that are created due to um, difference in movement of land masses against each other. Okay, so there might be a fault present over here, and the landmass might have moved along the fault. Okay, so we will learn in detail, I think, afterwards also, the faults and folds and the compression and the different tensional movements that are playing a role. Now, what are exogenic? Exogenic is mostly these processes are happening on top of the Earth's surface, and usually there is some natural agent which is, playing a role. For endogenic, most of the, the maximum role is played by the plate tectonic movements. Okay, but for exogenic, we have the natural agents, kind of, making these processes happen. So you have weathering, you have erosion and deposition. So these are three very important processes in geomorphology, in geomorphic processes, which help in changing the landscape and forming the landforms. Changing the landscape happens when you have weathering and erosion. So weathering can be physical, chemical, biological. Physical is mostly that the composition of the area does not change, but we can see physically there is change in the appearance of the area over there. Okay, so maybe there was a big boulder of rock present over there. Okay, due to weathering, this big piece of rock has, got fragmented into smaller pieces. Okay, so this is your physical weathering. Chemical weathering will happen when this rock had a certain composition. Okay, due to precipitation of newer material because of action with water. Okay, there is a newer material or there's a coating of a newer material on top of this rock and then it disintegrates. Okay, so that will be a combination of your chemical as well as your physical weathering. Biological weathering, as I had given the example, when animals burrow, okay, they form burrows, okay, so that is when there is some physical as well as a biological element that is playing. Okay, so some animals or some creatures they secrete something. Okay, so that will maybe cause some changes in the chemical composition of the rock itself. Okay, so then that would come under biological weathering. Then you have erosion. Okay, erosion is when the material is taken away from a place. Okay, so you have weathering happening. Okay, then erosion is that weathered material is transferred from one place to another. That is erosion. Now, this erosion, needs the constant action of any of the natural agents. So you have running water. So if there is a river, okay, so river is causing the weathering also, and then it is transferring the weathered material from the place where it has occurred to another place. Okay, so this transfer is actually the erosion. Okay, the material is taken away from a place. So it can happen with running water, it can happen with groundwater, glaciers, waves, and winds. Okay, so these are actually the natural agents, okay, that are mainly uh, considered when we are talking about geomorphic processes. Okay, so you have running water, groundwater, glaciers, waves, and winds, waves, currents, and winds. Now these are helping in the transfer of the material. Okay, so at a certain time, these agents themselves will deposit these material, these weathered material. Okay, so when they deposit, okay, that is when a landform is formed. Okay, there is a landform forming. During weathering and erosion, landscaping is happening. Okay, landscape is changing of that area. Okay, from somewhere the material has been taken out. That also becomes a landform where the material has been taken out. Now this taken out material, this transferred material is getting deposited at one place. Okay, so this is also then called as it is also creating a landform. Okay, so again the same natural agents are actually also depositing and forming new landforms. Okay, so you have erosional landforms and then you have deposition landforms. Okay, so this landform creation happens due to the geomorphic processes. Okay, because of different agents. You have endogenic agents also, you have exogenic agents also, the processes. Okay, so this is uh, kind of uh, an outlook of what composes of geomorphic processes. Okay, so we have discussed
Ma'am,
this. Yes.
how the waves and currents works like the geomorphic agents?
Okay, so right now I will just explain in short because there is a entire module where we will be learning about how waves and currents. Uh, for example, you must have seen sea cliffs. Okay, cliffs, rock cliffs nearby coastal areas. Yeah, or you have seen beaches. Now your
Yes, ma'am.
sea cliff is actually formed due to the action of erosion of waves. Okay, so material because of the constant hitting of the waves along this face of the cliff. Okay, so due
And
to
sea
this,
waves.
yeah, sea waves. So the sea waves are constantly hitting this rock over here. Okay, now the water, the first of all, the force with which it is hitting can cause fractures or cracks in these rocks, okay? And when these cracks actually become much larger and they get connected to each other, the material from there falls off. Okay, so
Yes, ma'am.
slowly, this is where the material will start. This is the place, like the bottom of the cliff is where there is major contact of the water. So slowly, this area gets eroded. Okay, then what happens when this entire area gets eroded? Now there is only this hanging part left. Okay, now because the entire lower part is absent now, so because of the higher weight of this, because this part gets heavier, this will topple off. So now this phase has gone back. So this actually happens over years. Okay, that's what I meant before also. The scale of these processes, it takes a long time.
Yes, ma'am.
Yeah. So this is how the erosion action of waves can create this landform, this rock cliff. Now, similarly, depositional landform, the best example is your sea beach. Okay,
Yes,
so
ma'am.
yeah, so the rocks are getting disintegrated, and any material, if you put you expose them to natural agents, they start disintegrating in smaller particles. So these rocks, they are probably transferred, and with the transfer also, we will talk about this in different this processes. The sizes of these fragments also decrease. Okay, because of the erosion and because of the effect of abrasion. Okay, so now suppose you have the sand particles. Okay, so the sand particles are also deposited by the waves at the beach front. So this is again the action of the waves. The waves are bringing material with itself, and it is depositing. Now both of these have different dynamics. One place you are having erosion, one place you are having deposition. Now what matters is the kind of force that there is. Mostly you will find the rocky beaches, okay, where usually they say that the waves come with a lot of force. Why? Because over there, because of the kind of, the setup over there, you have more rocks over there. Okay, so you have, higher force of the water over there, so they can erode over there. But along beaches, the sea waves are calmer compared to what you find in rocky beaches. So they're depositing over there.
Yes, ma'am.
Yeah. Huh.
Yes, ma'am.
Any more question on
So,
this?
is ma'am, is there a difference between waves and currents,
Yes,
or
currents.
both are?
Currents are a bit different. So currents are actually kind of a cyclic thing. Okay. So I think it will be better when I explain this when we are doing the fluvial geomorphology and as well as the wave. Over there, it would be easier for me to make you understand how currents are, forming a kind of a different landform. Is that okay?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. So this, as you said, as I just explained, that erosion of by a natural agent can form a different kind of landform. Deposition by the same natural agent can form a different landform. So we will learn all the different kind of erosional landforms and depositional landforms created by each and every natural agent that are listed over here in the upcoming weeks. So as I explained this already, so I'm not extending my explanation in this, that increasing population, obviously a burden of on Earth's resources, and overexploitation itself can cause, as I said, the building of the roads, the sand is being excavated from beaches, deforestation. Okay, so these are problems that are aggravating the effects of natural processes. And then we see that we are facing a lot of natural hazards because of that. So, some brief explanation of, natural geohazards and anthropogenic. Anthropogenic is when human influence is there. So, naturally, we know that there are volcanic eruptions that are happening. Okay, because of, mantle material spewing out of the volcanoes. Then you have earthquakes, that is because again because of the movement of plates against each other or towards each other or away from each other. Okay. Then you have atmospheric, disturbances caused due to cyclones, hurricanes, tornadoes. Okay. Then tsunami is a after effect of any major earthquake that is happening, under the ocean. Then you have landslides and desertification. These are also naturally occurring. Okay, when the intensity of it is low. Okay, it is not, it's not causing much damage to, it usually never used to do that before. Now it's considered a hazard. Okay, because the intensity and magnitude both have increased. Then you have sinkholes. Sinkholes themselves are, formation of sinkholes is a geomorphic process. Okay, but because it's causing damage to a lot of property, okay, so now it can be considered as a geohazard. Now, anthropogenic, your sea level change, that is the most common, kind of anthropogenic geohazard that we are seeing right now. You have pollution, okay, and then damming of rivers, and because of outburst of these dams, then there's, man-made kind of floods that are being created, and also wildfires, while wildfires can be both kind of, natural and anthropogenic. Okay, so but right now we are considering wildfires because the frequency of these wildfires have increased because of kind of, the human influence. So that is why we are considering it as anthropogenic. But all the natural ones, okay, so these are caused due to either endogenic geomorphic processes that we have talked about due to the plate movements, or exogenic, okay, where a natural agent is actually, causing these processes to occur. So there are factors, okay,
Ma'am,
yes.
how can we wildfires be natural?
Okay, so wildfires sometimes are natural in areas where, the temperature reaches like a very high temperatures, okay, and the moisture content also becomes very low. Okay, so sometimes we can see, or, you have lightning striking. Okay, it strikes one tree and then it is ablaze, and then if it, kind of starts expanding, that is also a natural way of wildfires happening. And if you see sometimes, very, very dry grass which has, very low moisture also, if they, just suddenly they can catch fire, and then that also can become a natural one. So, but mostly wildfires, right now that we know is, they say that like it's mostly man-made. Like maybe somebody just lit some, naturally available grass or hay, in fire, but it starts spreading. Then it becomes very unmanageable for us to control, and then it can turn into a wildfire if there is, a very large vegetative area that is present over there. Is that
Yes,
okay?
ma'am. Thank you. Yes, ma'am.
Yeah. So the factors, now the factors that we are going talking over here are actually the natural, kind of factors that are playing a role in the different earth processes. So as the prime kind of, focus for this course is going to be on natural agents that are working. Okay, so you have your wind, water, glaciers, etc. So these are some of the different, landforms that are formed due to wind. Okay, these are some examples, the formation of dunes, okay, and different ridges. Okay, so you can see that even we will see that how the different shape of dunes are also formed due to difference in the speed of the wind and the kind of obstructions that they face. Okay, so we will see that there are, you know, much more, internal factors also that are going to play a role in, different kind of earth processes and formation of these landforms. Now the elements also, how the elements play a role is, uh, there are some minerals which can get weathered faster compared to other minerals. Okay, so if we have clay minerals, okay, so clay minerals can get weathered or disintegrate much faster, okay, than quartz mineral. Okay, any rock that is made up of mostly quartz, that rock will get weathered at a lesser rate compared to a rock which has more clay type of minerals in them. Okay. Also, there are some minerals which are like not clay minerals, but they can weather very quickly and they can disintegrate or change their chemical composition into a clay mineral. Okay, so they also have the that is also a major factor that plays a role in the different kind of geomorphic processes and the kind of landforms that are formed due to that. Okay, so, and we have already discussed, how role of plate tectonics and structural features, kind of play a role in geomorphic processes. We will learn this later on also, how if an area has, a fold mountain or has a fault. Okay, there is a fault, how, there could be a change of the direction of the flow of the river, and it can also cause change in the kind of position or the dimension of a landform. Okay, so they also have an effect on the changes that we see in different landscapes. So these are some of the major factors that are playing an active role in the different earth processes. In this subject, mostly we will be focusing on the natural agents that are causing these or forming these landforms and causing these landscape changes. So another basic thing that we kind of this course has is the understanding the Earth's energy budget. Okay, so Earth's energy budget, as we told before, that Earth system is a closed system, so there is mostly transfer of energy and almost no matter. Okay, so the as we know in any it's a universally accepted law that energy is neither created nor destroyed. Okay, so there is only a transfer and transition of energy from one form to another form. Okay, or there is a transfer. So Earth in itself, to maintain its system, okay, so it has to keep the budget intact, as in the input energy. Okay, so the energy that is coming in, okay, it has to equate with the energy that is going out. Okay, so this is kind of a very layman kind of understanding of how the Earth's energy budget is kind of acting. So you can see in this diagram in itself, okay, so you have most of the energy that is received by the Earth is due to the, solar radiation. Okay, now the energy that is coming in, okay, due to the solar radiation, different kind of processes and different kind of factors play a role in either absorbing this energy or reflecting this energy, refracting this energy, or converting it into a different form of energy. Okay, so the energy budget actually, to understand that, we see how the different kind of how different of these how these different processes are actually playing a role in maintaining the Earth's energy budget. Okay, so it has been calculated that the average amount of solar energy that is falling on 1 square meter of Earth's surface is 342 watts. Okay, so your 342 watts is the average amount that is forming in like one small part of the Earth's surface. Okay, we are considering that. Suppose we consider this entire 342 watts, or units, okay, basic units. So we have 100 units of solar radiation coming through. Okay, it is being received by the Earth. Now, 30 units of this, 100 units, okay, will be scattered or reflected back to the space by the atmosphere. Okay, so this 30 units of 100 units is actually scattered back to the space. Okay, now these 30 units in these 30 units also, different units are actually being reflected back by different elements or different factors. So of these 30 units, 6 units are scattered by air, water vapor, aerosols, then 20 units by the clouds that are present in our atmosphere, and 4 units are reflected by the Earth's surface itself. Okay, so 30 units from the 100 units, some part of it is already being reflected back by the atmosphere and the elements of the atmosphere, and some part is reflected back directly from the Earth's surface itself. Now the 70 units of that 100 units which is reaching the Earth, again different processes are going to uh, you know either play a different role in maintaining this energy budget again. From the 70 units, okay, so that is equivalent to 240 watts per square meter. Okay, so that is 70% of 342 watts per meter square. Okay, so of these 70 units, the clouds, the atmosphere again absorbs 19 units of this. Okay, so then we are left with only 51 units of solar radiation. Now these 51 units are going to be absorbed by the Earth's surface. Okay, now that too, there is going to be a difference in the kind of absorption that is happening. Okay, different features of the Earth absorb different wavelengths of the these kind of energy that is coming in. Okay, so over here, as you can see, it is mentioned shorter wavelength solar radiation. Okay, the visible range of the electromagnetic spectrum is actually absorbed by land, water, and vegetation. Okay, so 51 units of this, the incoming 100 units. Okay, so you can see that almost half of the energy that is coming to the Earth is actually not reaching the Earth or not being utilized by the Earth per se. So you can see almost half of it is gone outside or it is absorbed by something. Okay, so we are left with only a bit more than half of this energy. So again, now these 51 units interact with the Earth's surface and the features of the Earth. Okay, so 23 units, okay, of the 51 units that is absorbed by the Earth's surfaces, okay, is lost again due to some of the processes that are happening on the Earth. So 23 units are actually used up by for evaporation of water. 7 units are again, kind of used up in the conduction and convection, or that is, sensible heat. Convection and conduction, as it's important for the kind of the different heat transfers that are happening on the Earth's surface. Okay. So of the 51 units, your 23 units are used up for the, evaporation of water, and 7 is again gone. Okay. So the remaining part of those 51 units, okay, are then emitted from the Earth's surface as infrared radiation, also called as terrestrial radiation. This radiation is different from the these kind of 4 units that are reflected back by the Earth's surface. Okay, over here you can see that this is scattered or this is reflected back to the space. Now over here, this the remaining of the 51 units, the terrestrial radiation is different. They are in the form of infrared radiation. So now, with a lot of calculations that have been done, it is said that the Earth radiates 117 units away from its surface. Okay, not 21 units. As we can see, like if you subtract 23 plus 7 from 51, apparently this should come up to 21. But that is not the case. Okay. So the Earth radiates 117 units away because it receives solar radiation during the daylight hours. Okay, but the incoming 100 units only happens in the daylight hours. Okay, but the the radiation back from the Earth's surface is also happening in the night hours also. Okay, so that is why we can see that the Earth's radiation back, okay, is actually more than this calculated one. Okay, so only 6 of these 117 units are actually emitted back into the space. The remaining 111 units of that infrared radiation, okay, that are being, again, emitted through the atmosphere outside into the space. Okay, most of them are uh, absorbed by the greenhouse gases and the clouds. That is how, the heat, if this, if this is how we see that only 51 units is, interacting with the Earth's surface, and even then most of it is going out, then how is the heat maintained in the Earth? Obvious. So we need to understand how is this heat maintained below the atmosphere and between the atmosphere and the Earth's surface. So then we understand that the remaining 111 units of the infrared radiation, that is, being reflected or, or emitted from the Earth's surface, is actually uh, being, absorbed by the greenhouse gases and clouds that are there in the atmosphere. Okay, so much of this infrared radiation, almost close to 96 units, is kind of then emitted back, okay, from the atmosphere to the Earth's surface. So the infrared radiation, okay, 111 units is absorbed from the atmosphere, absorbed by the atmosphere, the clouds and the greenhouse gases. Now, out of those 111, 96 units are again emitted back from the atmosphere to the Earth's surface. Okay, this is a greenhouse effect. Okay, if this entire thing that I said, that the infrared radiation that is being emitted in both day and night, if this process was not there, okay, so Earth would have no heat to sustain its life systems, or the other system that is there. So this is an important process that happens on the Earth, okay, where the infrared radiation is actually happening from, is being reflected from the, or radiated out from the Earth's surface, absorbed by the atmosphere. Then again, the absorbed energy, some part of it is again reflected back to the Earth's surface. Okay, so this is an important aspect of the Earth's energy budget, and this is why greenhouse effect to some extent is required by us. Okay, now since it has intensified because of again human influences and our activities, so but to a certain amount, to a certain limit, greenhouse effect is necessary for us. Okay, to have the heat that is necessary for our life systems to thrive. Okay, now another process that takes place, or which has this energy transfer that we've been talking about, it also plays a role, is called the albedo effect. Okay, so what is albedo? It is the measure of how a surface can reflect light. Okay, so usually people, correlate white color, okay, with, this albedo effect. Okay, so there are like, some people say that, how we say that white color reflects all of the light that is falling on it. Okay, so albedo effect, that is there, it follows a similar kind of a principle. Okay, so you can see over here, I will just zoom in on this. So if you have warming, okay, and the melting of sea ice is happening, okay, so the ice that is there, since we, as I told, the white color is sometimes, okay, if we go with that concept, your ice is white, your snow is white, okay, so it will reflect most of the light that is reaching it. Okay, so if your ice cover or snow cover or glacier cover is actually reducing, then more and more of that light, of that radiation, is going to be absorbed by the Earth. Okay, which is going to increase the temperature, and then it's a cyclic process, and it will melt more of the sea ice, and that in itself is going to give rise to a warmer weather or climate. Okay, so usually how albedo is measured is 0 to 1. Okay, so it's like in like decimal points. So if an object has like there is
Ma'am,
the yes.
ma'am, please explain it once again.
Okay, so
Warm
I
method.
will explain it with respect to ice. Okay, so albedo effect is how a surface can reflect light. Now it can also depend on the kind of smoothness of the surface also. Okay, so if your surface is smoother, it is easier for the light to hit it and then get reflected. Okay, so it will happen in just like one pathway. But suppose there are lot of bumps, and there are other particles present over here. So the each and every particle and each and every kind of feature on the surface will scatter the light in different directions. Okay, so that again plays a role in the albedo value. Okay, and some places if the material absorbs the light, okay, nothing is being reflected back, then again because obviously now your light again it's a radiation, okay, it's an electromagnetic radiation, it will the energy that is carried from it is going to change into heat. Okay, so that is why albedo is important for us to understand how the the light interacts with the earth's surface, and how the heating and the warming of or cooling is actually going to take place. So albedo, like if a material can absorb all of the incident radiation, all of the incident light, then it will have a zero value. And if the albedo is 1, that means the material reflects all of the light, all of the radiation that is falling on it. Okay, so higher the albedo, more it reflects. Now people have calculated and seen that snow or ice have higher albedo effect. Okay, they have higher, they are nearly close to the value is 1. Okay, so right now if the snow cover decreases, that means the albedo or the reflected light, okay, is also going to reduce, and more light or more radiation is going to be absorbed by the earth. That is where we were seeing now the energy budget. Okay, only some part of it is actually absorbed by earth, and then again it is emitted. Now if that increases, okay, so more radiation is going to get absorbed by the atmosphere, and that 96 units right now, okay, so that is the total. Now if your that increases, okay, right now we were talking about 342 watts, and some only 200 some watts is actually being is interacting with the earth. Okay, now in that watts, if that if the amount increases, okay, or the units increase in that sense, so we'll have more heat, and that is what is leading to the warming of the atmosphere or warming of the earth's surface. So albedo gives us an understanding of how much how much snow or how much ice cover we are losing, and what is going to be the effect of that. So that is with the normal albedo of snow, almost nearly 1, okay, and charcoal is 0.04. Albedo is a physical phenomena, but understanding its application or understanding its consequences with respect to earth processes is a bit different. Albedo is an effect, is a physical phenomena. Did you understand how the change in the ice cover, that what I'm explaining?
Yes, ma'am.
Huh. Okay,
But
so
I
yes,
have a question.
yes, yes.
Ma'am, we listened that the glaciation or melting of glacier are related to the global warming,
Yes.
are related to the greenhouse gases. But here, albedo is not something which is related to greenhouse gases.
No, albedo effect is not related to the greenhouse gases. Albedo effect, if If the overall albedo effect is decreasing because of decrease in the ice cover, okay, so that means more energy is going to be absorbed. It is actually related first to the energy absorption by the Earth's surface. More energy absorbed, then, according to the proportion that we discussed before, more energy is going to be given out by the Earth's surface. And then more energy is going to get absorbed by the atmosphere, and from there again it's going to be reflected back to Earth. So over here, as you can see, this is not related to greenhouse effect, directly, but it is indirectly related. Okay,
Yes, ma'am.
so this over
Yes,
here,
ma'am.
so more of melting sea ice. Okay, it's since if the warming is increasing. Okay, so your ocean is more exposed and lower albedo, so it will kind of absorb the energy. Okay, and due to that, your it's going to get heated up faster, and because of the heating of the already atmosphere, okay, and the absorption and kind of emittance of that radiation again, the temperature of the Earth's atmosphere is increasing, and then again it's a cyclic effect. There is no direct relation, but albedo effect, decreasing albedo effect is actually playing a role in increasing the heat of the earth, which in itself is again, aggravating the greenhouse effect that we are already seeing.
Yes, ma'am.
Okay.
It means that glaciers are melting,
Hmm.
and as the greenhouse gases increase in the atmosphere, it
Hmm.
will influence the melting of glacier more and will change the albedo of the earth.
Yes. Yes.
Yes,
So it's
yes, ma'am.
indirectly related, but all of them have a relationship with each other.
Yes,
So
ma'am.
albedo effect is just one physical phenomena that is it is already playing a role. But the changes in the temperature is either it will enhance it, or it will kind of deteriorate it. And according to that, it's going to affect the weather and the climate. Okay, so now you can see even in this one. Okay, so if you have larger amount of smaller droplets, okay, compared to cleaner conditions, it will have higher albedo. Okay, where you can see this is the indirect effect, cloud albedo effect. Okay, so larger the droplets, the larger the particles. Okay, so there is more surface area, and it can get scattered. And if the kind of smaller the particle, okay, there is less scattering, okay, and absorption. So all these are actually kind of they have an interrelationship. So if snow melts, okay, and the underlying surface, the earth's surface is exposed, okay, so that that barren land is going to absorb more solar energy, and hence it will capture more heat. Okay, and it will emit also that large amount of that energy, and then again that is again reflected back to the earth. So it's a cyclic kind of a process. Okay, so this is what is albedo effect, and how an earth's energy budget, it needs to stay in kind of a balance. Okay, the energy gain and the energy loss, okay, by earth's surface, there needs to be a balance. But due to these differences, okay, differences, either human influence or even natural processes themselves, okay, so they cause a change in the earth's energy budget also. So this is what we try to understand from this albedo effect. Now this is kind of like an exercise for you. These slides will be uploaded later on by the NPTEL team. So you all can either solve this, as per all the units that I have mentioned in the content. Okay, so there are three slides where you try to understand the radiation balance for Earth's surface, radiation balance for Earth's atmosphere, okay, and then a total radiation balance of Earth's surface and atmosphere. Okay, so you all can try this. Otherwise, in like the next class that I will conduct, I will first start with this, and I will give the answer to this. Okay, so for today, we will only cover till albedo effect. Then, uh, I think in the next week's class, we will start again with the content again starts with some part of the energy budget. So we can cover from that, and then we will move on to how surface water acts as a natural agent, and what are the kind of different landforms that are formed because of that. So any questions you have right now, so you can ask me now. And obviously a lot of questions were asked, so thank you for that. Yes, GS, you can ask now.
गुड इवनिंग मैम।
Yes.
आपसे पूछना था मैम, जो कोर्स लिया उसमें लेक्चर कुछ और मेंशन था प्लेट टेक्टोनिक्स से रिलेटेड, पर ये वाले लेक्चर्स जो आपने स्लाइड में अपलोड किए मैम, ये डिफर कर रहे हैं उनसे।
अ, मतलब उसमें आपको क्या दिखाया है प्लेट टेक्टोनिक्स में?
मैम उसमें कोर्स लेआउट में इन द वीक 2 इट हैज बीन मेंशन्ड दैट द लेक्चर विल बी ऑन इंटीरियर ऑफ अर्थ, प्लेट टेक्टोनिक्स एंड सी फ्लोर स्प्रेडिंग।
Yes. So that will be in more detail. This is only like week one. Week one में आपको थोड़ा थोड़ा brief दिया गया है ना सब चीज़ों का।
All right, ma'am. So
हाँ.
that the course 2, the lecture that has been missed out will be covered in the next one.
Yes, it's not missed out. So this part is actually corresponding to the week one of the lectures. Okay, अब अगले ट्यूसडे हम और एक लाइव सेशन करेंगे। तो कोर्स कंटेंट में मतलब जो कोर्स का जो भी है दिया हुआ है लेक्चर का जो भी दिया है जो प्रोफेसर का है, मैंने उसी का मैं समराइज करूंगी। तो अगर उसमें प्लेट
All right,
टेक्टोनिक्स कवर किया है तो मैं भी उसको उतना ही कवर करूंगी। सो दैट इज हाउ,
all
तो कि
right,
क्या
ma'am.
है आपके डाउट्स भी क्लियर हो जाएंगे और दूसरी बात है
हाँ जी
आपको
मैम,
असाइनमेंट में भी हेल्प हो जाएगी।
जी मैम, थैंक यू मैम।
Okay. Thanks for attending and thank you for asking questions. So
Ma'am,
this is
one
a
more question.
yes, yes, sure.
Ma'am, what are the reason behind the convection currents beneath the earth?
Okay, convection currents beneath the earth. Uh, have you heard of the dynamo effect or the dynamo that is considered in the Earth's core? Okay, so it's like a kind of a action or relationship of your magnetic field as well as the Earth's rotation. Okay, this will be explained better in the plate tectonics part, but I'll just give you a small overview. Okay, so the magnetic field that is generated due to the rotation of the Earth, and the Earth's inner core is actually made up of your iron and nickel. Okay, so more it's composed of that. So both the at least the iron being a magnetic mineral, so there is a magnetic field also that is generated, and due to the rotation of the earth, okay, so these convection flows that are happening is actually a consequence of the role played by both these effects, the rotational effects as well as the magnetic effects. And as I said before, the inner core is actually solidifying. Okay, because of that also there is kind of a temperature change. Okay, there is a release of energy also because of that cooling of the earth's inner core. Okay, so all of these together, they are actually they help in forming these mantle convections inside. Okay, so this will be explained better when I'm covering the plate tectonics in a a, in a larger portion in the I think in the upcoming a week. Okay, and I will get a better answer for it. So you can come in the next week's lecture, and I will surely include that also in the slide. But it's just like
Okay,
a brief kind of understanding of it.
okay, ma'am. Okay, ma'am.
Okay.
Thank you.
Yes. Any other question from anybody? Okay, so if there are no more questions, so obviously these slides will be uploaded by the NPL team later on, so you can revise also. And every week on Tuesday, we will meet from 6 to 8. And please attend and get your doubts cleared. And obviously, this is a live interactive session, so such question answer and understanding the course and understanding parts of the courses will be obviously helpful for you. And obviously, it's an experience for me because I'm a PhD scholar, so this is a part of what I do and what I will be doing in the future. So again, thank you for attending. And any problem that you have or any other doubts, either from this lecture, these weekly live sessions, or in the course content, you can also ask in the discussion forum. So either the TA or the tutor in charge of this course will answer it. And if any question are related to these live weekly session content, I can kind of answer it, or the tutor, any of us will answer. So please do ask questions in the discussion forum if you have any, and obviously you can keep a note of your questions and doubts, and you can interact with me in the live session also. So the first part of this course is going to be a little more general understanding, and such brief explanations, or concepts. And later on we will dive into all of the specific kind of geomorphic processes that is carried out by different agents. So obviously that is going to be more interesting, and to understand and see how they are forming. So I will end the lecture now. Thank you for attending, and hope to see you again in the future live sessions. Thank you.
Thank you, ma'am. Thank you, ma'am.